This is going to be a review unit of Unit 1, Parallel Lines and Triangles. And we did a lot of different sections in this, and so this is a sampling of problems from each section. Some problems will not be, some sections will be covered more than others, just the way that this generates the review questions. So what I would suggest doing is if you have a section that you're particularly struggling with, review that section. And if some of these don't, whatever ones you don't get on here, then go back and review that section, maybe the review video for just that particular section. Also, the best way to get use out of this is to pause the video, try to do the problem yourself, and then come back and see and check your work and see how it's done. So this first one is, we're talking about isosceles triangles, and it tells us that the base angle, if I draw this triangle, and these are my congruent sides, I'm going to call these my congruent sides for isosceles. Remember, this is the vertex angle, and then these two right here are my base angles. One angle is 54 degrees, so that means the other one has to be 54 degrees, and we're trying to find this missing angle up here. Well, we know if we add all of them together, plus this vertex angle, they have to equal 180 degrees. So all I have to do is say this is 108, plus I'm going to call this angle A, equals 180, subtract 108 from both sides, and so A is equal to 72 degrees, is my vertex angle. The next one deals with side lengths of triangles. If I have a triangle, and one side is 2x plus 2, and the other side is x plus 3, and the third side is n, what are the possible lengths of that side? Now remember, this is where we have to add them and subtract them. So if we add these two together, 2x plus 2 plus x plus 3, that has to be greater than n. And n has to be greater than if we subtract these two. So then I have 2x plus 2 minus x plus 3. Notice I put parentheses because we need to subtract everything, not just the x. So if I simplify both sides of this equation, I'm going to get x, and 2 minus 3 is minus 1, is going to be less than n, and then 2x plus x is 3x, and 2 plus 3 is 5. So n has to be greater than x minus 1 and less than 3x plus 5, which is this one right up here. This is just one of those from our first unit where we were talking about simplifying and solving equations with multi-step equations. So this is kind of tricky because it's going through, it says after he uses the distributive property like terms, additions to property, and isolates the variable on one side and the constant term on the other side, what are the possible values of the constant? Now we're not solving for x, we're just identifying what the constant can be. And the reason there's two answers is because depending on which side we move the constant to and which side we move the variable to will make a difference. So if we simplify this by distributing, we get x plus 3 plus 4 equals, and then we distribute this as well, negative 1 minus 4x minus 12. Now there's two ways I'm going to simplify, so x plus 7, and this is negative 4x minus 13. So there's two ways I can do it. I can get x to this side and the constant to this side. So if I'm going to write this again over here. So one way is I'm going to add x to both sides and subtract 7 from both sides. So in this case I have 5x, that's 0, that 0 equals a negative 20. So my constant value is a negative 20. Well, what if I would have done it the other way? What if I would have moved x to this side and the constant to this side? So in this case I subtract x from both sides and I add 13 to both sides. So I get 0, and in this case I get 20 equals negative 5x, and negative 13 plus 13 equals 0. So in this case I have a positive 20 as the constant value. That's why there's two answers. You're not trying to find what x is in this case, we're just trying to find the constant. So it's going to be negative 20 or 20 depending on which side you move the variable to. So in triangle DFEKJ, so from here to here is 50 units. And what is the length of EK? So now we want to know how far it is from this other part. This is the median, remember, so EK has to be twice as long as JK. From the vertex to the centroid is twice as long as from the centroid to the opposite side. So 2 times 50 is equal to 100. two parallel lines, E and F are our parallel lines. Notice those are the ones with the marks right there. They're crossed by two transversals. What is the measure of angle 15? So we're looking, here's angle 15. So we're only looking at this section right here. Well, the only angle we have is 97 degrees. And 97 degrees and angle 15 are called alternate exterior angles, and we know that they are congruent. So measure of angle 15 must also be 97 degrees. This is a multi-step equation. What's the first reasonable step? Well, remember we've got to get rid of parentheses, so the first thing we've got to do is distribute on both sides. So that one is the first one. We've got to distribute first on both sides. Here we have triangle DEF as isosceles, where DF is congruent to FE. So these are my two congruent sides of my isosceles triangle. And we've bisected this. So this 29 degrees, that's got to be 29 degrees as well. So it's finding, now the question is, what is the measure of DFE? So we want to know the measure of DFE. We want to know the vertex angle. Well, if we know that this bisects it, 29 plus 29, so that whole angle is equal to 58 degrees. Because it's an isosceles triangle, we know this is 58 degrees. And so we have 58, plus 58 plus angle F is equal to 180 degrees. And so 58 plus 58 is 116 plus angle F equals 180. We subtract 116 from both sides, and so we get the measure of DFE, what I've called F here, is 64 degrees. All right, consider these two planes. We've got a few things here. We're marked, this is perpendicular, and then, so these two planes are perpendicular, and then we've got lines running in both ways. So in this diagram, the only figure that could be parallel to line C, so here's our line C, which one is parallel? Well, it has to be in the same plane, and the only one that's in the same plane that it doesn't look like it's ever going to cross is D. So that is the only line that could be parallel to line C. What is the measure of angle ABC? ABC is this angle right here. And remember, this is called an exterior angle. And we know about our exterior angle theorem that it's equal to the sum of the two remote interior angles. So if this is the exterior angle, the remote ones, here's an interior angle, but this one's, we want the remote ones, which means the ones that it is not touching, which would be this one and this one. So angle ABC is equal to 67 plus 60, which would give us 127. That's the remote exterior angle is equal to the sum of the two remote interior angles. In this case, we have two lines and a transversal, and it's saying what must the value of x be so that these are parallel lines. We want to make sure C and D are parallel. Well, we have two values. These are called, they're both on the same side of the transversal, and they are inside the parallel line. So these are same side interior angles. And we know that they add up to equal 180 degrees. So we're just going to solve for x. We're going to say 3x plus 45 plus 81 is equal to 180 degrees. That's 3x plus 126 equals 180 degrees. Subtract 126 from both sides. So we get 3x equals 54. And divide by 3. So x is going to equal 18, because that's what it's asking. What is the value of x? X will need to be 18, because then if we substitute that in, 3 times 18 plus 45 is equal to 99. So this would be 99 degree angle, and 99 plus 81 is equal to 180, which is why if we have the same side interior angles add up to 180, then the lines are parallel. So if we have an equilateral triangle, remember equilateral, we have ABC. Equilateral means they're all the same length, the sides are all the same length. A perpendicular bisector is drawn from angle A to this side, and it bisects it at point M. So if it bisects, a perpendicular bisector means it is 90 degrees, and then it makes these two sides congruent as well. So what is the length of MC? We want to know the length of one of those sides. Well, we know the perimeter equals 96. So 3 times x equals 96. If I give every side is x, like AB equals BC equals AC. So there's 3 of them. They're all the same side. So if I divide by 3, I'm going to get the length of one side. So divide by 3. So x is equal to 32 millimeters. Well, that's the length of the whole side. Well, if I bisect that, that means I cut it in half. And to find MC, I just need to divide this by 2. So MC is equal to 1/2 of 32, which is equal to 16 millimeters. So make sure we're looking very closely at what they're asking for and know our rules about perpendicular, what does bisector mean, and so forth. What is the value of x in the equation? So here's one we're just going to solve for x. So we distribute first, and we get 2x plus 6 equals 4x minus 4. If I subtract 4x from both sides and subtract 6 from both sides, because those give me 0, so I have negative 2x equals negative 10. Divide by negative 2, x equals a positive 5. In this case, we have a triangle ABC, and we have segments that are drawn and they intersect at this point G. And we know FG is equal to 6, and we know FC, the whole thing, is equal to 18. So which best explains whether point G can be a centroid? Now remember, a centroid tells us, if this is the centroid, then I know that GC is equal 2 times FG, because from the vertex to the centroid is twice the length as from the centroid to the opposite side. Well, how far is GC? Well, we know the whole thing is 18, so GC must be 12. And then we look at that and we say, well, is 12 2 times 6? And that is true. 12 equals 12. So the ratio of this side to this side is equal to 2 to 1. That's another way of writing ratios. 12 to 6 is, and that's just kind of like reducing a fraction. 12 to 6, 12 divided by 6 is 2, 6 divided by 6 is 1, so the ratio is 2 to 1, which is what we need. If there's a ratio of 2 to 1, then it is a centroid. So point G can be a centroid because 12 to 6 is equal to 2 to 1. Which type of triangle will always have a perpendicular bisector that is also an angle bisector? So if we look at a triangle and we're going to make this perpendicular and those equal, which one is always going to have that happen? Well, let's take a look at a right triangle. You can draw all sorts of right triangles. I can draw one like that, I can draw one like this, I could draw one like this. Okay, if we do a perpendicular bisector, is that always going to be, in this case, I can very clearly see that because to draw a perpendicular bisector, I can't draw it from on this right triangle. A scalene triangle is one where all sides are different. Obtuse triangle means, you know, we've got an obtuse angle. And again, you can have lots of differences. The only one that makes sense is the equilateral, because if an equilateral triangle, we know that all of these angles are always equal, and so when we draw a perpendicular bisector, it's also going to bisect those angles. So that one you just kind of have to reason your way through by what you know about triangles. So if we're trying to solve this equation, which equivalent equations might Katrina use? So let's just distribute first and see what we can simplify. So this is x minus 2x minus 6 equals 8x plus 12. Now I've got to distribute that negative as well. Minus x minus 4. And if I look at this, does this match any of these over here? X. So if I look at my first one, x minus 2x minus 6, that checks out. 8x plus 12 minus x minus 4. That one works. Now these next two are the same thing, except I've got some different, this is plus 4, which we know that's not it, so we can cross those off. And then this one is got a 3, so we can cross that off. So let's look, now if we simplify this, I'm going to have a negative x minus 6 equals 7x plus 8. And which one of those, because they all have this negative x plus something over here, the only one that works is that one right there. So those would be your two answers. Again, if you have any questions on any particular section, I would suggest reviewing that particular section's review and then Take good notes and use one page of notes and take your test. Good luck.